Hey guys, a quick video to expand on some basic skills and tricks that can be helpful. So the file we're working with is here, this basic skills example file, and when you open up, it should kind of look like this, all right? And we'll just kind of work our way through some of these. Some are kind of short, but just very helpful and useful to know, okay? Now, in lecture, we talked a little bit about how Rhino can actually work with solids and solid operations. So here I have a sphere that's sort of a quarter embedded into a cube like this, all right? Now I'll actually kind of copy these to the side a little bit, so you can kind of see some of these operations step by step, right? So Boolean difference, right? Essentially, if you just start typing, and you get your couple of like Boolean commands here, right? And so the one we'll try is Boolean difference, and to subtract from, we're gonna select this one to subtract from. Basically, it's subtracting an operator A with an operator B. So enter, and then to subtract with, I'll subtract with the sphere, and basically you should get this. Okay. Again, and I'll just like copy these over so they're side by side. Okay. Now, as you can kind of assume, then Boolean intersection should be basically their Venn diagram. So first set this guy, right? And now you can like right click, or you can enter, you can space bar. They all work the same. You can do this guy, and you should be left with their intersection. Right? So this is really useful, for kind of figuring out intersections of things or not, right? Boolean Union, as you can see, Boolean Union, okay, to union, and this is simply just select everything that you want to join together and enter, right? Now the difference is like essentially that you'll see that these get merged, right? And so if I try to kind of find an angle where you can kind of see in side, essentially that like the sort of intersecting surface here between these two guys is actually kind of voided out, right? So this would be a continuous surface. Actually, if I explode it, you'll see. But basically, it would try to kind of join it into one, like that, right? So these that and that is kind of now joined together. I pulled it apart just for you so you can kind of understand, right? All right, Boolean split. Let's run Boolean split, okay? And then just select them all, enter, cutting surfaces, and basically you would get all three parts, right? So this is kind of like a conjunction of like all these together, essentially, right? If you wanted all the operators. Yeah, okay. Now, this guy here, these guys here, this is sort of an extension of the same idea. Oops. Except, let me undo that while I copy these over. So let's say you have several volumes like this, rectangular volumes or boxes that you can make using this box to corner, right? Like that. And they're all touching, right? And the way, obviously, you want to essentially use your snaps to make sure that they are kind of really connected and they're really touching each other, right? But essentially what you can do is you can like connect them all and run a Boolean union, which means that like they will now be kind of treated as one entity as opposed to four separate ones like this, right? Once you're done with that, essentially what you would want to do, and actually I don't need this one because this is just a sort of progress thing, is that I want to kind of merge all the coplanar faces, meaning that if this face and this face are basically kind of on the same surface, or they're on the same plane, then let's kind of do without this sort of middle stuff inside, right? Let's do without the things that are kind of merging in between, okay? So that's what the command here is called, MergeAllFaces, and all these commands are kind of listed at the corner of the box. So MergeAllFaces, okay? So select all of these, right? Basically do a crossing selection and enter. And you'll see basically essentially it cleans up all your sort of edges that are inside. Does it make sense? Okay. We can explode it just to see, okay, what it actually did. Is like even the sort of, that wall that was on the inside, right, that originally is here, that's right there, is now kind of deleted or cleaned up, disappeared. Okay, so that's what this does. It basically, if it looks for all your coplanar faces and merges them if it's possible. If it's not, then usually it means that you might be slightly off or they're not actually really coplanar. All right. Okay. This one is actually a little trick, essentially, that I like. And it's and you can see, okay, it's under Tools, Options, Modeling Aids. So modeling aids, these settings I've covered before, but it's always good to just like re-emphasize, right? This makes your life easier and faster, is to enable SmartTrack, enable the dotted lines. You can leave these as default. Make sure that these things are the ones that are kind of ticked. I think by default, Smart Ortho might not be on. Smart Tangents, it might not be on. Okay, permanent points might not be on. Okay, cursor tooltips, snap, distance, point, command prompt. Right, these are kind of my settings, right? But you can experiment. But these are ones that I found generally to be very, very useful. All right, now to kind of demonstrate the behavior of some of this, actually I will copy this up a certain amount. Okay, now these distances, these marking sort of dimensions are just there to kind of show you the relative distances, but I'm actually just going to do a polyline. Okay, and for example, as you know, with our snaps, like the midpoint snaps actually lets me kind of draw this sort of center line, this line, very easily by just snapping to the midpoints of the sides, right? And whenever you're looking for like the center of a square like this, then you basically get that by drawing a cross. Okay. Now this, if let's say if I need a distance that's 3 units off of like one point or the other, that's where this comes in really handy, because I can basically hover over it, right, and drag it in that direction, right? And when this is on, this means that it's kind of tracking off of this. You see that sort of little cross, the little blue cross is a sort of relative point or a temporary point. And so I can now use my number pad, right, and just type in 3 and enter. So meaning that actually it will actually execute the start of the polyline command at 3 units off in the direction that I was dragging, right? And so this way I can draw this like that. 3, whoops, I can undo that. Be careful. So now this is sort of on ortho, meaning that it's sort of tracking orthogonal directions. I prefer this to using the ortho mode, which is more like that. Okay, this is the ortho mode. Simply because it lets me move my cursor around freely, and I can tell more exactly when it's snapping and when it's not, right? And so if I'm still kind of like on an ortho, it's snapping to a ortho direction, then I can type 3 again, right? Which basically kind of draws that point, enter to, or right click to basically execute that command, right? Okay, so by kind of using the same technique, right, I can do this again. So you can kind of hover over here until it starts to like grab it, and then drag it in that direction, right? So, and start it at 2, for example, and draw this direction and 2, whoops, 2, right, like that, and enter to close it, right? And so this is really handy for these sort of situations. And basically it allows you to kind of start your line, right, off of a reference point, and then draw in a direction off of a reference point as well, right? Instead of having to, let's say in this example, I would have to draw 0.5, enter, and then try to basically come in and then move it in that direction 0.5, right? It allows you to just like start drawing from 0.5 off of this point, essentially. Okay, so it's a kind of like handy trick. Once you master it or once you learn it, it will kind of making drawing and starting lines off of specific reference points a lot easier. Let's say if I wanted to start this point in this direction, 0.75, so I can just type in 0.75, it would start out that way, right? And can basically start to draft a lot more quickly. All right. All right, next one. This is called the MoveFace command. It also has a brother, which actually isn't here, called MoveEdge. But so you type MoveFace, all right, and you can select the face. So for example, this guy, okay, spacebar, enter. Direction constraint equals normal. This setting should be on by default, but basically this allows you to kind of it's similar to the push and pull tool in SketchUp, right? So if I run it again, then and you sometimes it'll snap to certain things, so you can kind of you might want to control that, right? But it also allows you to kind of set distances. So I can say 0.5, right, in that direction. So I can actually set dimensions when I'm pulling this, or let's say let's pull it upwards, 0.5. Right, it actually snaps to that dimension when you actually input it, and then you can click, right? So there are multiple ways to do this, right? Now, one thing to be careful of, it works best when things are like, more or less orthogonal, but you can actually try to, let's say, skew it. So, for example, if I do this interface, right, and then I move it, but if I click on the direction constraint and say none, for example, then you'll see it actually allows me to move all over the place, right? So I could potentially do something like that, right, and skew it just a little bit. But the downside to that is, let's say if you do something like that, then your model gets kind of weirdly inverted, and this geometry kind of will cause you problems. As you can kind of see, that face is inverted and all this sort of stuff, right? It can cause problems with the geometry. So you want to be careful with that. Okay. Now its brother, MoveEdge, okay, is actually very similar in the sense that, let's say I pick an edge and I can move it. Right now this is set to directional constraint none, which means that I can kind of do stuff like this, right? If I did set the directional constraint to, and there are actually different ways, but let's say vertical first face normal, then it will actually only allow me to slide in one direction, right? Now it's constrained to that first face, like that, okay? Or I can set this to something else, right? Second face normal, which means it's like that, okay? So it's just a different version of kind of manipulating the edges, right? And the same kind of rules apply. Let's say an edge like this. If I try to move it, it will do. You can actually kind of do things like this, right? A sort of chisel shape. Or if I set it to none, then you'll see that, like, you start to do weird things like that, right? Where the surface starts getting kind of curved and bowed if I moved it downwards, okay? So while it's powerful, it can yield sometimes weird geometries that may not be exactly what you want, but in some cases it might actually give you some surprising results like this. So just be careful with it. Okay, next one here. ProjectToCPlane. Now this is one that I actually like a lot because I use a lot, simply because when you're modeling in 3D, certain things tend to happen. Okay, so this is an example, and actually I'll switch to the top view here for this. Is that, let's say you're on this is some sort of urban plan, right? Like these are buildings. Let's go to shaded mode. So let's say these are some buildings that you're kind of looking at it from the top view, and you're trying to trace basically like a plaza, right? And copy this to the side. Okay. And if I'm trying to trace this plaza, usually, I'm going to use this, like the polyline, right? I'm trying to snap into points. I'll do this on the purple layer. And what happens, let's say if I'm doing this, right? I'm saying I'm kind of trying to basically snap into points here. And then this last point, I'll just type in close or C, right? Using this option, C, spacebar to close it naturally, okay? Now, in the top view, it does look like I'm tracing it correctly, right? But what you'll see is that when I switch to the perspective view, right? Well, all these heights are different, right? Because, you know, when I was snapping, let's say from the top view, I didn't know if I was snapping to the top of the cube or the bottom of the cube, right? Sometimes it snapped to the bottom, sometimes it snapped to the top, sometimes, you know, like this is not a very good way of kind of controlling it, right? So even though it looks accurate in the top view, it's completely off in the bottom. And actually this point isn't even in the right place. So I'll actually show you how to fix that really quick. So just like highlight it and use the move command, snap to it, right, and say, oh well, okay, no, well, actually none of these points are actually really on it, right? There's no sort of intersection, right? So in this sort of case, you actually have to draw your own or kind of make your own, let's say, reference point, right? So to take these two guys and type intersect, which basically finds their intersection, okay, the intersection between these two volumes. And then we'll move this, oh, not the whole thing, whoops, 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 okay. Highlight this, right? You can actually just click on the point and drag it. So I'm holding down, right, click and drag, and getting it to snap to that point, and then letting go. Yeah, that's one way of doing that, right? So that ensures that you're actually at the proper intersection of these two guys, okay? All right, so the ProjectToCPlane command is actually used to basically take this sort of 3D shape and basically flatten it, okay? So I'll just type ProjectToCPlane. Delete input object, I'll set it to no just so you can kind of see. Otherwise it can, you know, be deleted. And so you'll see basically that is on the top view, these are perfectly aligned. Okay, both of these lines are perfectly aligned, but essentially that's what the sort of projection in 2D of what it would look like essentially on the ground, right? And this would actually be the correct outline of the, let's say, the plaza in this sense, right? So this is super useful. That's to kind of show you that. Okay, now project is kind of like the same idea, except like C-plane, you know, usually is set to your XY plane, which is this, right? This sort of checkerboard, right? This is the XY plane. The construction plane is usually the XY plane. There are, you know, commands that actually allow you to modify or change it, but for the most part, you know, unless you're doing something that's predominantly on an angle, we don't change it, right? Now, project actually is a little bit different, and so I think in this case we'll try, and this is just an example of similar, not dissimilar to what we just did earlier, right? So you have something like, and I'll delete this guy. So let's say if you went through and just traced these points just like they are here, right? Just basically similar to what we did earlier, and said, okay, well, there's a plane that I want to project it onto in this direction, right? So this plane is like kind of replacing or substituting for the C-plane, for the construction plane. It can be any plane, right? Meaning that you can actually project to any geometry or any like planar surface if you really wanted to, all right? And so basically project, select curves and points to project. So we'll select this, enter. Select surface and polysurface mesh to project onto, meaning that like it can be a single surface, it can be a poly surface. Okay, just remember that it can actually be poly surfaces. So select this guy to project onto. Now I'm actually doing this wrong first. So you'll see when I press enter, it basically projects in the direction of your view, or it tries to project in the direction of your view. So right now it says projection missed the selected objects, right? Okay, so to do it the right way, let's try it again. So I'll select this guy, okay, and I'll actually switch my view to this one, the front view, right? Basically make this the active view, and I'll select the plane from here and enter. And so you have to basically pick one of these like views for it to project in the right direction, essentially, right? So this would be kind of projecting that way, right? And so you will have to switch to one of these views to actually get the projection to work correctly. Okay, so you'll see that guys basically got flattened in that direction. Okay, so that's the gist of the ProjectToCPlane, basically the family of these commands and what they do. All right. Now this guy, I'll do all the sort of operations just like right here, but this is kind of where we're going. This is a trick that I use for, let's say, if you have 2 floors, right, and you're trying to build a staircase between the 2 floors, and you know your steps are equal, right? You know the amount of steps, you know how many steps you want, or you know roughly how much this should be, okay? And you just draw this sort of connecting line between the 2 corners where you want the stairs, all right? You take it and you just divide, and you say divide by, let's say, 20. So it automatically gives you 20 subdivisions, right? 20 sort of segments, right? 20 segments actually equals 21 points. So there will be actually 21 points. Actually, if I do this, you'll see 9 and 12, basically 21 points added to selection, right? If you do this, there's 21 points and 1 curve, okay? So it's 21 points, basically that's how many sort of steps you have, okay? Now I'll make, just use the box, really kind of ghetto style. And where is my, okay, I've enabled my point sort of snap. And I'm just going to eyeball this. But let me just make a really sort of, let's say, step like that, okay? Doesn't really matter. Just illustrating the point, okay? Then I can just copy, and you can either like do this, right? 1, 2, 3, several times, right? And just kind of stack it like that using these points. Or you can do a couple and just like kind of use that as a guide to copy and use that as a reference to kind of do it a little bit faster, right? This is just like that, right? And the last one actually intersects with that last slab, so you actually don't need that, okay? So quick and dirty, easy way to basically kind of subdivide and do stairs really, really quickly, right? You don't have to necessarily kind of do the math, or you can just let Rhino kind of do the math for you, right? Now, if you wanted these to actually match basically perfectly, then you could essentially do this sort of box command, but use this first height as a snap, right? And so this would actually be the perfect height to fit onto here. And so let's actually do that real quickly here. Delete that. Okay. So basically then I can take this, move it over here, right? And then when I copy it onto the next couple, you'll see that because I use those points as a snap, that they basically mesh, or they fit perfectly, right? This is the right height for it to basically be the right sort of thickness as a tread. Okay, all right, really cool, simple and easy. All right, this guy is essentially kind of showing how I would, in a very sort of quick fashion, try to draw a ramp. Okay, now ramps are tricky because you kind of have to like draw the sides and all the stuff. You want the ramp sort of slope to be consistent, especially for ramps like this that are curved, right? It's kind of hard to figure out. Okay, so we take these 2 lines, we extrude it. Oops, not extend, but extrude. Do the extrude command and do that. Okay, and actually let me switch back to the default layer. So this is a little bit easier to see. Okay, so you have these 2 sort of curved walls right now, all right? And the command is this, InterpCrvOnSrf. Okay, so basically interpolate curve on surface. So select surface to draw curve on. So we'll start with the outer one first, okay? And the start of the curve is there. And you'll see basically this allows me to draw on the curved surface, okay? And the end of the curve is here. Now, you can actually do multiple, so you can actually do that, and kind of change the sort of, right, geometry of the curve, right? If you really want, you're trying to do a slip and slide, right? But that's not what we're trying to do here now. So start of curve on one end, end of curve on the other, and just enter or right click, okay? Same with the other guy, start and then end right there, okay? So you can take these guys and sort of hide it for now. I'm using the hide command just to hide it, so you can see, okay, that's my ramp now, okay? Now, the sort of next thing here you can see, and there are actually several different ways we can do this. You can just like take one, and just let's say loft one to the other, just to kind of fill it like that, right? Which kind of fills in the gap, okay? Which is somewhat similar to what we're doing here, okay? And then that's just like a simple loft command. And we can then actually, let's say if we take these two, right, and then copy vertical, this is the vertical sort of option. So like it goes vertical, right? And let's say, this is out of scale, but let's just say 1 inch, right? And in this case, let's say we're trying to make these into balustrades, right? And this is kind of where we want to end up, okay? So what we're going to do here is just use the line or the polyline command and just like draw one line segment that goes vertically from here to here, okay? And then say ArrayCrv, okay? Select objects to array will select this sort of vertical post, enter. Select path curve, which is this guy. And you say, well, you'll see, actually it should give you a preview. So let's try to do, let's say 20 of these. So now if you don't actually do, if you see that, all right, that's kind of like the wrong sort of result, right? Because it's actually using the sort of curve rotation. This curve actually does have a rotation because of how it's built. So let's try that again. Select object to array, enter. Select path curve, no rotation, meaning that it should stay straight. 20 of them should be vertical just like that, okay? And so we can take this guy, copy it over to that side, and then do another ArrayCrv. Select objects, select path curve, like that. Make these sort of the same, 20 of them. Voila, you have sort of balcony balustrades, right? Along, arrayed basically evenly, distributed evenly along a curve. Now, do note that, you know, this sort of spiral ramp probably does not conform to code because of the sort of double curvature and slant that it has. So this would not be the way to build a sort of code conforming ramp, right? There's something else you would have to do. The process would be a bit different, okay? And then the last thing I show here, I believe, is the pipe command. If you look at this pipe command right there, meaning that we can essentially try to select everything that we want to thicken. Let's say we do that, and holding down the control, I will deselect the main sort of ramp surface and these two side curves. I'm just wanting to pipe these balustrades as well, so just make sure that's what you're kind of selecting. Okay, pipe radius is probably something like 0.02 in this file. Okay, and it just makes pipes with thickness out of using those poly surfaces, or using those polylines or those curves as the guide. Okay, so quick and dirty. It's just there for visualization. There are kind of better ways to build things like that more accurately, but I think that's a sort of really fast way to do things. All right, that's it.